If you want to understand how big things really are, you have to start with what small even means. And it turns out there's a limit, a theoretical basement to the universe called the Planck's length. We don't actually know what's down there, not because it's hidden, but because the laws of physics stop being useful. It's the point where space itself might become pixelated. To imagine it, if a single atom was the size of Earth, the Planck length would still be smaller than a single bacterium crawling on that atom. It's the smallest measurement that still has any meaning. Below it, there's no distance, no smaller, just math that stops working. Above that, you get elementary particles, the building blocks of everything, quarks and electrons. These are not like marbles. They're more like locations in a field. No physical size we can detect. We've never seen an edge. They might be truly point-like. But even with no size, they still matter, because they're the ingredients. Group 3 quarks and you get a proton or a neutron, the solid core of every atom. This is the first step that has measurable size. A proton is about 100,000 times larger than the Planck length. Still too small to see, but now we're in the world of units that actually exist. Link a proton with an electron and you've got a hydrogen atom. Most of that atom, empty space. If the proton were the size of a pea, its electron would be buzzing somewhere 50 feet away. All atoms are mostly nothing, just little clouds of probability orbiting tiny cores. But when atoms stick together, the real structure begins. 2 hydrogens and 1 oxygen becomes a water molecule, and now you have something that behaves. Water bends, sticks, dissolves. It forms droplets, flows, freezes, and steams. A single drop of water holds more molecules than there are seconds in the history of the Earth. Bigger molecules, like sugars, fats, or oils, are just longer chains of the same idea, atoms arranged into patterns, loops, and branches. Their shapes give them function. Stack hundreds of atoms, and you get complex structures, coils, sheets, and spirals, things that move, twist, and interact. These are the pieces that make up life. At a certain size, those pieces pack together, and you get a cell. Cells aren't simple blobs. They're structured machines. Surfaces, gates, compartments, and motors, all packed into a unit so small you could fit tens of thousands on the tip of a needle. Inside a single cell, you'll find strands of genetic code, tiny engines that burn fuel, and thousands of parts that sort, ship, and recycle. Your body is made of about 30 trillion of them, and every one came from the division of a single cell. Stack cells together and you get tissue. Tissues form organs, and those form you. A human stands about 6 feet tall, made from trillions of organized machines, each made of molecules, each made of atoms, each made of particles that might not even have size. Next to us, a grizzly bear is several times heavier. A giraffe could look you in the eye from a second-story window. And a blue whale? That's as long as a basketball court and weighs as much as 25 elephants. Its tongue alone weighs more than you do. But it's still small. The largest living thing on Earth isn't even an animal. It's a fungus underground in Oregon, connected across over 4 miles of forest floor. One single organism, one genetic individual. That's the kind of size that starts to feel geographic. The Burj Khalifa, the tallest building on Earth, rises over half a mile into the sky. The Great Wall of China stretches over 13,000 miles. And yet, from even low Earth orbit, they vanish completely, because the Earth is 8,000 miles wide. It spins once a day, orbits the sun once a year, and curves so gently that it feels flat on the surface. And yet, its size holds an atmosphere, a biosphere, and 8 billion people walking around at once. The Pacific Ocean, on its own, is wider than the moon, and the atmosphere, the sky we breathe, is thinner than the skin on an apple compared to Earth itself. But next to Jupiter, Earth shrinks fast. Jupiter is over 10 times wider and more than 300 times as massive. Its storms could swallow continents. Its magnetic field stretches millions of miles. And then there's the sun, a ball of fire 100 times wider than Earth. It makes up 99.8% of the mass of our entire solar system. You could fit 1 million Earths inside of it. But instead, we orbit around it at just the right distance to survive. Zoom out again. The solar system doesn't stop at the planets. It stretches out for billions of miles, past icy comets, dwarf planets, and the faint boundary where the sun's influence fades. The whole thing spans space so wide, it takes light, the fastest thing in the universe, hours to cross it. Beyond that is interstellar space. The nearest star system is over 4 light-years away. That's 25 trillion miles, a number so large it might as well just mean farther than we can reach. But that's still nearby. All of these stars, the sun and its neighbors, sit inside a single spiral arm of our galaxy. Our home arm is called Orion's Arm, and it's just one strand in a spiral disk called the Milky Way. That disk contains hundreds of billions of stars spread across 100,000 light-years of space. Every star you see at night is just in our local neighborhood, a tiny sampling of what surrounds us. The galaxy has shape, it has rotation and structure, with clusters, gaps, arms, and a center we'll never reach. And we sit quietly in one of its middle lanes, orbiting like a passenger on a giant spinning wheel. The Andromeda Galaxy, our nearest spiral neighbor, is 2.5 million light-years away, and that's just one of many. The Milky Way and Andromeda are both part of a group of dozens of galaxies, a local group, which itself sits on the edge of a massive region called the Virgo supercluster. This structure spans hundreds of millions of light-years and contains thousands of galaxies. Beyond that, superclusters, filaments, walls, and voids. The cosmic web, a network of matter that stretches across the universe, looking kind of like a 3-dimensional spider's nest. All of it packed into a sphere of sky called the observable universe, a ball centered around Earth, not because we're in the middle, but because that's how far light has had time to reach us. That distance, over 90 billion light-years across. And it's still just the visible part. There could be more beyond. We'll never know. That's the scale. From the smallest length physics can define to the edge of what light allows us to see, not steps, not categories, but one smooth continuum. Every piece fits inside the next, from a point with no size to a structure that contains everything.